Hey, boys and girls, this is Mr. Bell, Mr. Bell's Math. We're going to get after it. We're going to start talking about evaluating expressions, all right? Solving them, getting an answer, okay? Last video we were talking about setting them up, what words to look for, how to make an expression, okay? But now we're going to actually get an answer from an expression. So what I want you to start with is think back to the video that we just did. It says, recall that an algebraic expression contains one or more variables, okay? You can substitute a number for that variable and then find the value of the expression. This is called evaluating expression. So what I'm going to do is I'm going to do a few examples so you can see how it's done. All right, now this is pretty straightforward stuff. There's no words. At the end I will have one word problem, okay? But this is mostly to get you into the swing of things, how to do the problem. So in this example I have x minus 9. All right, this is a semicolon. All right, it's just punctuation. It separates this from this. This tells me that x equals 15. Okay, so I have to plug in. Let me change colors here to red. I have to plug in the 15 for the x. Okay, so I'm going to rewrite the problem and say 15 minus 9, and then I solve it. What is 15 minus 9? 6. Okay, that's all there is to it. Let's look at the next one. All right, now this is a fraction. That doesn't make it any different. We still have to find the answer. So my answer, or my problem, is 16 over n, which means 16 divided by whatever the value of n is. All right, and it tells me right here, once again, it's a semicolon that separates this from this. This n says it's equal to 8. So I have to go and plug in 8 for n. So I have 16 over n. And then I'm going to say that's the same thing as 16 over 8. All right, and that is an 8. And then I just simplify. What's 16 divided by 8? Because remember, this fraction bar represents division. So what's 16 divided by 8? All right, and if you were to write that as a division problem, it would be 16 divided by 8. The top number always goes inside. Bottom number always goes outside. Well, my answer is 2. Okay. So that just tells me that my final answer here is 2. Okay? And how we would actually write that if we wanted to, we could say, all right, 16 over 8, or no, let's not say that. Let's go back here. Let's go back a little bit. 16 over n equals 2 when n equals 8. Okay? That's how we would actually answer it. All right, let's look at another one. Here I got 6k. All right, let me get my pointer tool. 6k. All right, and what do we do when k equals 1/3? All right, well now here we have the variable equaling a fraction. Okay, once again, nothing changes. We substitute the fraction for the k. So I have 6, and when you have a number and a variable next to each other, it means to multiply. So 6 times 1/3. Okay, now we just think back to our multiplication of fractions and whole numbers. I turn this into a fraction. It's always going to be over 1 when we're doing it with a whole number. Then I multiply 6 times 1, and I multiply 1 times 3. And I wind up with 6/3, and that simplifies to 2. Okay, so we can say 6 times, or no, let's back up one spot here. 6k equals 2 when k equals 1/3. All right, simple, simple, easy peasy. Let's do another one. And this one I like. I'm gonna get whoever gave me the cold. All right, this one I like because I'm going to show you two versions of this, okay, and how these answers can vary when you have parentheses and when you don't. So here we have 4 times whatever the value of x minus 4 is, okay, and it tells us right here that x equals 7. Okay, so let's go ahead and plug this value in and solve it. So I have 4 times 7 minus 4. All right, so PEMDAS tells us we have to do what's inside the parentheses first. So I do 7 minus 4, and I'll wind up with 4 times 3. Or you can write it as 4 times 3 like that if you wanted to. All right, Anyway, let me erase that as to not confuse us. All right, and let's just say, so I got 4 times 3. I went too far when I erased. And then 4 times 3 is 12. Okay, so we would say that 4x minus 4 equals 12 when x equals 7. Okay, and the next example, I got the same setup, except in this one I don't have a parentheses. Okay, so I substitute, and I'm going to go ahead and put that in parentheses, minus 4. And that just tells me I'm going to do my multiplication first. So I'm going to say 4 times 7 is 28, minus 4. 28 minus 4 is 24. Okay, so I'm going to just scoot back to this last slide. Here we had the problem, it equaled 12. In this problem, same exact numbers, just without parentheses, it equals 24. So I have 4x minus 4 equals 24 when x equals 7. Okay, when x equals 7. Now, the last one is the word problem, and it says that the expression 1.8 times C, whatever the value of C is, plus 32 gives the temperature in degrees Fahrenheit for a given temperature in degrees Celsius. Okay, so what that means is if I give you a degree or a temperature in Celsius, this equation right here, this expression, will put it into Fahrenheit for you. Okay, so it says find the temperature in degrees Fahrenheit that is equivalent to 30 degrees Celsius. Okay, so we just do it. Let's start with the expression. We got 1.8 times C plus 32. Remember, a variable and a number next to each other means to multiply. All right, now we're given a temperature in Celsius. That's what C represents, Celsius. So I say 1.8 times 30 plus 32. All right, and I didn't multiply this out beforehand, so let's go ahead and multiply this. 1.8 times 30 equals 54. And then I say plus 32. Now I did this because it's a multiplication. Multiplication is done before anything else in this particular problem. All right, so now I can do my addition. 54 plus 32 is 86. All right, and that would be 86 degrees Fahrenheit. Okay, so that's all there is to it. You know, if it gives you an expression and gives you a value to plug in, you just plug it in and then solve it using PEMDAS. And that's all there is to this.